So in the last video, we left off talking about how sarcomeres contract. We went through each of the different parts of the sarcomere. Just a reminder, you should be able to draw a sarcomere and label each of the different parts of it. And you should be able to understand what each part does. So on this, we'll identify the A band, I band, Z line, H band, and sarcomere. So first, this part here is the A band, and then right in the middle is the M line. Then we have the I bands here on either side. We have the Z lines right in the middle, so this is the end of each sarcomere. And then the H band in the middle. The sarcomere is the length from one Z line to the other. And if we had to guess, which one do you think is contracted? So hopefully you're thinking the bottom one. The sarcomere up here is relaxed. The Z lines are further apart, and then on the bottom, everything kind of got squished together. So this would be the contracted one. Okay, so into the myofilaments. This is super, super important. This is how muscle contraction happens. So there are two different types of filaments. There's thick filaments here on the left and thin filaments on the right. The thick filaments are made out of a protein that kind of looks like a golf club called myosin, and it has a core that's titin that's kind of springy protein. Oops. Thin filaments are primarily made out of actin. So actin are the little golf balls here. But there's also troponin and tropomyosin, and we'll go through each of those in a minute. So first, thick filaments, like I said, kind of looks like a golf ball, this protein here. So this is myosin. This is a myosin protein. 200 to 500 myosin molecules will come together to make these thick filaments. They're kind of wrapped around each other, and then the little heads stick out. So the tails align with each other, and then the heads are kind of repelled from each other. This results in this little bare zone right here in the middle, which will be important once we're talking about muscle contraction. These little heads are the part that are going to bind to the actin on the thin filaments, and I'll go through that in a little bit. So again, this is what the protein looks like. This is a picture, don't worry too much about it. There's the tail portion and then the head portion. On the head, a few things happen. So this is where ATP will bind, which is energy, and this is where ATP will get converted into adenosine diphosphate, and it will release the phosphate, giving energy for the head to bind to the actin and contract. And we'll go through all those steps later, so don't panic right now. Just know the heads are really important because that's where ATP binds and that's where actin binds. Thin filaments are made out of 3 proteins. So you can see the little balls here in orange. These are the little actin proteins. Then we have this rope of tropomyosin that kind of covers the actin. And then we have these little troponin complexes that kind of look like a sunny side up egg. So on the troponin complex, there are 3 really important parts to it. So this is where tropomyosin binds, this is where actin binds, and this is where calcium binds. So what happens is calcium molecules get released from the sarcoplasmic reticulum, and they come in and they bind right to where the yolk of the egg is, and it causes a big shift in all of this. So troponin will shift, which will pull tropomyosin out of the way, and that will expose the actin. You can see these little darker pink dots on the actin. It will expose that, and that's the actin binding site where the myosin heads will bind to. So we can see here a small part of a sarcomere. In purple, these are the thick filaments. So these are myosin with their little myosin heads. And then in red, these are the thin filaments. So this is just the actin you can see here. So myosin heads desperately want to bind to the actin. These two are very attracted to each other. The only thing stopping it is that tropomyosin rope that covers the binding site for myosin. So we need calcium to come in to move the tropomyosin out of the way so that the myosin heads can bind to the actin. So what happens is the myosin heads bind to the actin, and then they kind of pull, and then they'll let go, grab another actin, pull, let go, grab another actin, pull, kind of like a tug-of-war contest. This is another picture. You can see the myosin with the little head sticking up. You can see there's an actin binding site and an ATP binding site. And then here on the bottom, you can see the thin filament with the actins, the tropomyosin green ropes, and then the troponin with the calcium binding site, and the tropomyosin binding site. Don't worry about F and G actin. So other structures within the sarcomere is a protein called titin or connectin, and this is what's stabilizing the structures and gives it elasticity. Dystrophin anchors the myofibrils to the sarcolemma, so that plasma membrane. That's what holds the muscle to its cell membrane. And then myoglobin is a red protein that increases ATP production. At rest, it is binding to oxygen, but then when it's needed, it can release oxygen, and that allows the muscles to contract. This video does not work on my computer. If you guys play your slideshow, this should be able to work for you.